Okay, this is problem number 7. It's another linear programming problem. 7a asks us to graph the feasible region, so I've listed the constraints: x is greater than or equal to 0, okay, y is greater than or equal to 0, and then y is less than or equal to negative 3x plus 5, and y is greater than or equal to 2x minus 5. So the first equation, y is greater than or equal, or x is greater than or equal to 0, that will be that there. So this, let me label it up here, x is greater than or equal to 0. The other equation, y is less than or equal to 0, and that will be this here, y is less than or equal to 0. The next equation, let's see here, y is less than or equal to negative 3x plus 5. Graph that. My y-intercept is 5. I go down 3 and over 1. So that will be the equation there. Y is less than or equal to minus 3x plus 5. And I have to be below that line. And then finally the last equation here. That's y is greater than or equal to 2x minus 5. So my y-intercept is negative 5. And my slope tells me to go up 2 and over 1. Okay, so this is going to be the equation: y is greater than or equal to 2x minus 5. And that says I have to be above the line. So here's my feasible region. Okay, I have to be above the line, y is greater than or equal to 2x minus 5. Below the line, y is less than or equal to 0. To the right of x is greater than or equal to 0. And then above, well, let's see here. So y is, oh, I'm sorry, this is y is less than or equal to negative 3x plus 5. We're below the line. Not below, yes, we are below the line, okay, which is what I've indicated before. Okay, so here's my feasible region there. Alright, so what we have left to do then is to find the corner points. Some will be easy to do, some a little more work. This one here, that's easy to see. That's the equation, or 0, 0. So that's that corner point. This one here, that's the intersection of the line x is equal to 0, and then y is equal to, what's that, 2x minus 5. So let's see here. When x is equal to 0, we get y is equal to negative 5. Okay, so that's 0 minus 5. This point here, that's the intersection of two lines. Y is equal to 0, and then y is equal to negative 3x plus 5. So we have y is equal to one thing, y is equal to another thing. We set the one thing equal to the other thing and we solve. So 0 equals negative 3x plus 5. Negative 5 equals negative 3x. So 5/3 equals x, or about 1.67. So that's that point there. 1.67 for x, and then 0 for y. And then lastly, we have to find the intersection of these two lines here. So that's going to be, again, one equation is y is equal to negative 3x plus 5, and then the other equation is y is equal to 2x minus 5. Alright, and so again, we said y is equal to y and solve. So minus 3x plus 5 equals 2x minus 5. Here I'll let's see here, I'll subtract 5 from both, or add 5 to both sides here, and then I will add 3x to both sides. So that will give me then 10 equals 5x, 2 equals x. I can plug 2 is equal into, for x up into that equation, and I get y is equal to negative 3 times 2 plus 5, negative 6 plus 5, y is equal to negative 1. So my solution is 2 minus 1. which we see there. Okay, so I found all of the corner points there. Alright, so that was 7A and 7B. B asked us to find the vertices and show your work. Now C, so we don't need this information anymore. I can get rid of this here because we found our vertices, which you see listed there. So C asks us to check all of our vertices and see where we get a minimum and a maximum for the objective function p is equal to 2x plus 2y. Okay, so we have to list our corner points. Again, 0, 0. 1.67, that was 5/3. So 5/3. And then 0. And then 2 minus 1. And then finally 0 minus 5. So 2 times 0 plus 2 times 0, that's 0. Oh, that's not 5, 0, that's 0, negative 5. Oh, well, that was 5/3, I'm sorry. So 5/3, 0. Alright, and so when x is 2/3, we have 2 times 5/3 plus 2 times 0. And that gives us 10/3, which is 3 1/3. Alright, and then for the next point, 2, negative 1. So let's see here. We have 2 times 2 plus 2 times negative 1. So that's 4 minus 2, and that will equal 2. And then the last point, we have 2 times 0 plus 2 times negative 5, and that will equal negative 10. Okay, so our minimum is going to be negative 10, and our maximum is going to be 3 1/3, and that completes C. So, and then D asks us to find, or what is the maximum? Well, that is 3 1/3, and that occurs when x is equal to 5/3 and y is equal to 0. Okay, so that's it for problem number 7.